Morning, everybody. Welcome to day 2 of our class here. Going to go ahead and get started, and we'll just go ahead and add people as we go. So this is where we left off yesterday. So if you haven't, if this is your first time attending today, I suggest that you watch the video that's online. I've already posted the previously recorded videos, and you can go ahead and watch that, kind of go over the syllabus and give you an introduction to the class that way. One thing I do want to mention is, since the video I have is posted on YouTube, this goes for any of my videos on YouTube. If for some reason that you see an ad that comes up, just know that that's actually not me putting those ads on there. It's YouTube's. YouTube actually has the right to put ads on your videos whenever they want. Don't agree with that, but that's unfortunately what they do. So if you see a video up there, just know that I'm not trying to make money off of having students go to see my own videos. That's all of YouTube's doing. So now that we got that out of the way, we'll go ahead and get started here with continue with 1.2, I should say. So we did this yesterday. This is going to be where we left off before. We got 1 point. We talked about this yesterday here. And so now we'll continue on and go to the next couple of problems. So this section here, 1, 2, and also 1, 3, they're kind of like review because they're going over graphing lines. So you might have seen some of this before, but we'll kind of go through all this anyway, just to make sure everybody's all at the same spot. So we'll go ahead and do that. So it says, find the x and y intercepts and use them to graph the following equation. And here it is right here. Just to review, we did this yesterday. Right here, if you want to find the x-intercept, you put a 0 in for y and you solve for x. And then if you want to find the y-intercept, you put a 0 in for x. So what you're doing is you're actually putting a 0 into the opposite variable of the intercept that you want to find. That's how it works. If you want x, you put a 0 in for y. If you want the y, you put a 0 in for x, and that's how it works right there. Okay, so we'll go ahead and continue that with this one here. If I want to find the for this, the x-intercept, that means that the y equals 0. So if I put that in here, I get 6x plus 9 times 0 equals 18. That's 0, that goes away, and we get 6x equals 18. There's only one variable here to solve for, and that's x. We can do that by dividing both sides by 6, and we get x is equal to 3. And if you want to write that as a coordinate, since we put a 0 in for y, it's going to be 3, 0. And that would be the x-intercept. Now, when I find the intercepts, what I'm going to do is I'm going to plot them on this graph here. And then I'm basically finding 2 points. So then I can connect 2 points with a line, and that's going to give me the answer. So 3, 0. Okay, so starting from 0, 0, we go 3 places to the right, and then since it's 0, we don't go up, we don't go down, we're just going to stay right there on the x-axis, and so that's going to be 3, 0 right there for that one. Okay, so next thing we're going to do is we're going to find the y-intercept, and that's where we put in a 0 for x. So 6 times 0 plus 9y equals 18. 6 times 0 is 0. That goes away. We get 9y equals 18. Divide both sides by 9. And then we get y is equal to 2. As a coordinate, that's going to be 0 because the x is 0, we said first. 0, 2. So 0, 2, that's going to go right here. And so now we have these 2 points. You're just going to connect those with a line like this. And then that's going to be the answer. That's how we can graph lines, just by using the 2 intercepts. So that's our answer on that. We'll do another one of those examples down below here. But the basic idea is the same. You're finding the intercepts, you plot them, connect them with the line is the idea on these. So let's move on to the next example. So then this one, we're going to do x-intercept, put in a 0 for the y. So I have 6x minus 3 times 0 plus 15 equals 0. 3 times 0, that whole thing just becomes 0. That goes away. So we get 6x plus 15 equals 0. Now, in order to solve for x, we'll have to move the 15 over to the other side. So I'm going to subtract that to both sides, and we get 6x equals negative 15. Divide both sides by 6. We are going to get a fraction here. That doesn't go in evenly, but we can reduce the fraction. We can divide both of these by 3. Negative 15 divided by 3 is negative 5, and then 6 divided by 3 is 2. We get negative 5/2. Now, if you put that into a calculator, you're going to get negative 2.5. And so we do that just to make it easier for graphing. So we have negative 2.5 and 0. That's going to be the x-intercept. To plot that, we're going to go this direction. So 1 to negative 2.5 is going to be right here. Remember that if it's negative, you're going to move left. If it's positive, you're going to move right when you plot that. So that's why we go to the left here, because of the negative sign. All right, so that's the first point. And then now we want to do, we want to do the y-intercept. And that's x equals 0. 6 times 0 minus 3y plus 15 equals 0. That first part's going to go away. We get negative 3y plus 15 equals 0. We're going to subtract the 15 from both sides. So we get that. Could have also added the 3y to the other side. It doesn't matter which way you want to do that. Divided both sides by negative 3. Negative over negative is going to give you a positive. So we get 5. And then as a coordinate, that's going to be, look a little neater here, it's going to be 0, 5. So 0, 5 is going, so we start 0 means we don't go to the left, we don't go to the right, we stay on the y-axis. We go up 1, 2, 3, 4, 5. And we have a dot right there. So now we have our 2 points. We can just connect those again with the line. And it's a little harder to do that with these digital writing tablets here, but there we go. We got that. And then we have this other one like that. So that's what the line will look like when you connect the 2 dots together. Those are your x and y-intercepts. So x-intercept is where it crosses the x-axis, and the y-intercept is where it crosses the y-axis. That's basically the definition for what intercepts actually are. And this process here, by the way, this doesn't work only for lines. We can actually do this for any particular one. Like we did the previous examples we did yesterday had some squares in it. So it can be all different kinds, squares or absolute values. But this process will always work to allow you to find the intercepts here. All right, so now the next thing we're going to talk about is an idea that's called symmetry. Okay, so symmetry, I have this written out here in your notes. So we'll just kind of talk about this a little bit here. So symmetry is a fold line on that. And so I have some different drawings on that. So what happens is if I fold the graph along either the x-axis or the y-axis or through the origin, if I get one part to lay on top of the other one, that means it has that symmetry. For instance, this first picture that we see here, if we take this drawing and we fold that along the x-axis there, that means that this part is going to lay on top of this one if I fold it over on top of itself. So by doing that, that means it would have x-axis symmetry if I'm able to do that one. So the y-axis symmetry, it's similar, but then you're going to fold it along the y-axis. If you fold it along the y-axis, then that part's going to fold over on top of itself, and then this part will lay on top of there, so it has y-axis symmetry. Now, if it has origin symmetry, you're kind of folding it along across the origin like that. But typically what you look for origin symmetry is you have the same thing in the opposite quadrants. So either these two or these two. So you might have maybe something that maybe you might have a hill that goes up like this, and you have like another one that goes down, like that. They're both the same, but in opposite quadrants. That would tell you it has origin symmetry. So it's not necessarily a fold line with origin symmetry. It's more of just seeing the same thing in opposite quadrants. And that's how you can tell that. So that's what we're defining as 3 different types of symmetries. Now, one thing that we're going to talk about here is eventually we're going to look at, so if we have a graph, obviously we can look at a graph and we can tell if it has symmetry there, but we're going to be working with some problems where it's just the equation only. So we need to figure out a way to determine what kind of symmetry it has without going through all the graphing process. We're going to do that right here. We're going to talk about each of these separately. So right here, I'm going to go ahead and call this XY right there. Now, if I take this and I look at the same point down below here, what we're going to notice about that is the X values will both be the same because they're right above each other. However, the Y values are going to differ here. So I have a Y up here. That means I'll have negative Y down below for that one. So the X's are the same, but the Y's have a different sign. Now, if I take a look at this drawing here, this is XY right there. And if I take this across with Y-axis symmetry, then I have negative X and positive Y. That means the Y values are exactly the same because they're at the same level, the same height there. But the X values differ by a minus sign. Okay, so that's what we have with Y-axis symmetry. We have X and negative X. If we take 2 points here, so XY on that one, and then one down below here, that has different X and a different Y. So if 2 points are symmetric about the origin, that means that they're going to have opposite signs for both the X and the Y. So this idea here that I just drew on this, we're going to use this later to talk about whether points are symmetric or not, or how you can make a point that's symmetric based on what we're talking about here. And then so we're going to come into that a little bit later. So right down below here, we're going to come up with a way to tell algebraically whether something has symmetry or not. And that's the ones that are listed down below that you can see here. Okay, so with this one, we notice that for x-axis symmetry, they differ by the y's differ by a minus sign. So it says 2 points are symmetric about the x-axis would be xy and x negative y. 2 points symmetric about the y-axis would be xy and negative xy, as we can see here. And then 2 points symmetric about the origin would have opposite signs for both the x and the y, as we see here. So this down below is just a summary of the drawing that we did up above here. Okay, so we're first going to start off by looking at a couple pictures, and we're going to tell what kind of symmetry it has just by looking at the picture itself for each of these. Okay, so again, if you have pictures here, you can think of it as fold lines, where you fold something over, or if you're looking for origin symmetry, you just look at if there's the same thing in opposite quadrants. So if this one here, if I take this first picture and I fold it along the y-axis, I'll fold it over. The graph is not going to lay on top of this piece, so I know it doesn't have y-axis symmetry. If I do the x-axis, there's nothing below to have it fold over onto. So if I fold this over, it's not going to match up with anything down below because there's nothing there. So it doesn't have x-axis symmetry either, and I don't have anything in opposite quadrants. So this one, I'm just going to put none. Okay, so it doesn't have any of those symmetries. No x, no y, or the origin symmetry. Now the next one that I have here, if I look at this one drawing, I've got one part that comes up like this and one part that comes down like that. So I have the same thing in opposite quadrants. Same with this. I got a line going up like this and a line going down like that. That would be indicative of origin symmetry. So this next one has origin symmetry because I've got the same thing in opposite quadrants there. So that's origin symmetry. The next one, we've got this This part, if we fold this along the y-axis, means this part would lay on top of that part down below. So this would have x-axis symmetry only. It would not have y-axis symmetry, because if you fold it along the y-axis, this little part's not going to match up with these lines here. So it would just have x-axis symmetry only. For the circle that we have here, if I fold it over across the x-axis, the y-axis, I have the same thing in opposite quadrants. So this actually has all three symmetries. It's one of the very few graphs that actually have all three symmetries. If you have a circle or like an ellipse or something like that, it's going to have all three. So this has x-axis, it has y-axis, and it has origin symmetry. So it has all three of those there for this one. So again, you can just use the pictures of the graphs. You can tell that directly just by looking at them, what kind of symmetry it has. But we're going to be moving on to next here, how to test for symmetry without graphing, and that's what we're going to take a look at here. So I've already have this written out in your guided notes. So again, as a reminder, these guided notes are all going to be found within the My Open Math or on my website. You can find these guided notes that we're going through now. So x-axis. So here's all the rules for finding the symmetry without graphing it. So again, if you don't have a graph provided like above, this is what we'll look at. The x-axis, we're going to place the y with negative y in the original equation, and you're going to simplify it. So then if it simplifies to the same equation you started with, then we know it has that particular symmetry. The reason why we're talking about y and negative y is from above what we did before when we graphed these. We talked about that points that are symmetric about the x-axis will have the x, y, and x negative y. That's the reason why on that one. For the y-axis, you're going to replace x with negative x in the original equation. You're going to simplify it again. And if that simplifies to the original equation, it's going to have y-axis symmetry. If it doesn't, if you get something different, like maybe you get the same thing with an opposite sign, then that means it does not have that particular symmetry. And then for origin, replace the x with negative x, and you're going to replace the y with negative y. Simplify it again. If you get the same thing you started with, it's going to have origin symmetry. Okay, so knowing that, we're going to work with this equation, and we're going to do a couple review things, and then we're going to talk about the symmetry later. And I kind of spelled all this out, what you're going to do to find the symmetry. So we'll do this step by step here. All right, so first of all, we want to test the following equation for symmetry and find its intercepts. Okay, so for the x-intercept, you put a 0 in for y and solve for x. So I have 4x plus 0 squared equals 4, and I get 4x equals 4. Divide both things by 4, and I get x is equal to 1, which means that it would have 1, 0 would be the x-intercept. For the y-intercept, you put a 0 in for x and solve for y. And so if you notice, this is actually the same equation we just talked about yesterday. So I'm just kind of doing these again as a review here. Okay. So if you want to find the y-intercept, we put a 0 in for x and we solve for y. What I talked about yesterday is that, and some people were asking, how do I know if it has one answer or two answers? Well, if you have anytime you have a square, you're always going to get two answers on this, because when you take the square root of something, it's always plus or minus the square root. So plus or minus the square root of 4 means that you get plus or minus 2 as a result. That's the only way that you're going to get two answers, is either if you have some kind of absolute value, or if you have a square on it and you have to take the square root of something. That's the only way you get two solutions out of that. If you don't have a square and you don't have an absolute value, like something like this above, that means you're only going to get one answer for that. So this one, we're going to get 0, 2, and then 0, negative 2. That would be your two intercepts that you would have with that one. But now we're going to take it a step further, and we're going to test for symmetry. So what we mean by test for symmetry is that these instructions that I put above here, where you put negative x in for x or negative y for y, those ones we previously just talked about, That's what we're going to do to test for symmetry. So when you're testing for symmetry, you do have to show this work. So this work that I'm about to show down below right here, okay, where I test all three of these, x-axis, y-axis, and origin, you need to show your work for testing for symmetry on this. And that's how you're going to do that on an exam, okay? So for this first one, x-axis, if I want to test for x-axis symmetry, replace the y with negative y into the original equation. We're going to simplify it. If we get the same thing we started with, then it's going to have that particular symmetry. All right, so I have 4x, and then instead of a y, I'm going to replace the y with negative y. And then I want to simplify what results. So I get 4x plus, so negative y squared means I just get positive y squared there. And then so I simplified it. So anytime you have a negative raised to an even power, the negative sign goes away. But if you have a negative raised to an odd power, the negative remains. So in this case, the negative went away because I have a negative raised to an even power here. Now notice what I get. I get exactly the same thing as I started with here. So this is the original one, it matches. And so so this one, basically I would just put yes. Yes means that yes, it does have x-axis symmetry. So that's a yes for that. Now let's try the y-axis symmetry. Replace x with negative x and simplify. Okay, so we're going to replace that. So I have 4 times negative x plus y squared equals 4. I get negative 4x plus y squared equals 4. Now this is not the same as the original one. What you might be thinking is, well, couldn't I get rid of the negative by multiplying by negative 1? Yes, you can multiply by negative 1, but remember, you're not just going to multiply the first term by negative 1. If you're multiplying something by a negative, remember that you're going to do the entire equation by the negative. So if you do that, then you would get 4x minus y squared equals negative 4. Well, that's still not the same as the original one, so we're going to put a no for this one. No, it does not have y-axis symmetry because no matter what we do here, even multiplying through by negative, that doesn't change it to make it the same as the original one because I've got these minus signs, makes it different. So I would say no, it does not have that symmetry. Okay, so no for that. But then let's do the origin symmetry. We're going to replace both of these. So we're going to replace the x with negative x and replace the y with negative y. And then we're going to simplify this and see if we get the same thing we started with. We get negative 4x. Again, a negative raised to an even power means that negative goes away. So we get plus y squared equals 4. And that right there is not the same as the original one. So this is going to be a no as well. We got a question up here on the chat. How would you graph this example with a plus minus? So I assume that you're talking about this other one up here. For that one with the plus minus with the if you have this one back over here that we talked about before. Yeah, we are going to get into these, but we're not going to do that here in this section. In this section, the only ones that are having a graph are the lines, because this is something with a quadratic. This is something that we're not going to graph until later on, because we got to talk about the quadratic section first before we get into ones like that. That's where you have two x-intercepts or two y-intercepts. That's going to come into play a little bit later. So you don't have to worry about graphing something like that for right now. We'll do that a little bit later when we get into that one. Try to graph some of the questions. Okay, so for graphing these, let me hold on a second. Do I have an example of that a little bit later? So these, probably what they want you to do is make a table of values, most likely, for something like this. And since we're talking about that right now, I'll go ahead and I'll do that for this one. So if you want to graph something like this, so basically what you're going to be doing here is making a x and a y table like that. And so for something like this, probably what I would do first for that one is I'll go ahead and just put in, I'll probably solve for one of the variables here. So I would have for that, probably you want to solve for, in this case, we'll just go ahead and we'll just make this a y, x and y. So for instance, you would put in some values here, -2, -1, 0, 1, and 2 are typically some values that you would pick for something like this one. And what you would do is you put those into there for x, and then you would solve for y. And what you would do is you would get a table of points that you can plot in order to do something like this. So that's the basic premise of how you would do that. And so I'm going to go ahead and look into my open math just to see the type of questions that are in here for that one. And so I just want to make sure I explain everything that is for the homework on that. So if I look at the 1.2 homework that we have on this one, let's see, we have first two, we've got our linear ones on that. So question 1, 2 in your homework is that one here. And then for the other ones, the ones that you have are ones where you probably have an x squared and not a y squared. Those are a little bit easier to do. So for instance, for this, I'm going to, let me do an alternate example for you for that. So for instance, in the homework, there is a y equals x squared. Let's just do x squared minus 1. Let's suppose that's the graph that we want to plot. And typically for that one, it says use intercepts in order to graph something like this. So if it says use intercepts to graph, that means you would find the x and y intercepts and you would plot those. So let's do that for, I think I'm doing that. I have one of those coming up here. Yes. So I think what we're going to do is let's jump to this example now, and we're going to find the intercepts on it. And then I'm going to do a graph on this example for you. And then we'll do the symmetry later. So let's do this one instead, because the ones in your homework don't have you do something like this, where you have a y squared. It's more of one where you have an x squared. So let's go ahead and find the intercepts on this example, and then I'm going to graph it for you. So that way you can tell how you would do that, because that more resembles the ones that's in the homework for how you would do that. So let's do that one where we find the intercept. So again, the same one, put a 0 in for y and solve for x squared minus 5x. So for this kind of problem, this does require you to do a factoring step. So factoring means that you're going to pull something out of this. Factoring, you have a common factor that you're going to pull out. Both of these have an x in it. And so I'm going to factor out an x. Now, if you want to determine what goes inside here, you just take each of these individually and divide them by an x. In other words, if I take x squared and I divide it by an x, that's going to leave me with an x. If I take -5x divided by x, I'm going to get a -5. And so now I have this. Whenever you have something that is two things multiplied together and it equals 0, that means you're going to set both of these individually equal to 0. So I want to do x equals 0 and x minus 5 equals 0. So if either this one is 0 or that one's 0, the whole thing will be 0, which means that I get 0 and 5. That tells me that 0, 0 and 5, 0, those are going to be your two x-intercepts. Let's also put a 0 in for x and do this down here. X squared, 0 squared minus 5 times 0. I get 0 here, so I get 0, 0 for that one. And that would be considered so the y-intercept, notice that 0, 0 could be considered both an x-intercept and a y-intercept, so it goes to the origin. Now, let's go ahead and plot each of these, even though it doesn't ask us to do so. We're going to do this for the homework purposes only. And so I have that one right there. Okay. So now that I have this one complete, I have these two here. And so what I need to do is I need to find another point that's on here. if you have the squares like this, that means that the graph is going to look like this. So when you do this problem in the homework on that, let me go ahead and I'm going to switch to the homework. I have this up here for you, and I want to pull up the homework problem that we have. And so let's go ahead and look at this. You should now be able to see the homework screen that's here. This is one of the problems that you'll be doing. And notice that underneath here, there's different tools that you have underneath. So if you have a problem that has a square that's in it, for these kind of problems in homework, you want to actually click the tool right here that looks like it's a upside down a U shape. That's what you want to do on problems like that. So we want to select that particular tool. Now, in order to do this, like for instance, this one right here, you would have, for instance, if you would click on one of the points like this. And so this one right here, if you were to find the intercepts on that, if you put a 0 in for the x, you would get -9 for the y. So down here at -9, there would be 1 point. But then notice that when you move the cursor, it moves it up and down to some different coordinates. So if you were to put a 0 in for that one and set it equal, so you'd have 0 equals x squared minus 9, what you would get is 3 and -3, because if I put a 3 in here, I get a 0, and if I put -3 in here, I would get 0 as well. It's like a difference of squares. So you can factor that by using difference of squares, x plus 3, x minus 3. So for this kind of problem, what you would do then is you would go to 3, you go ahead to the 3 and click on it, and that would lock in your answer, and you would hit submit, and then it says it's correct. And I would just go ahead and enter my intercepts here for that one. So in this case, I would have to enter in what they're asking for is actually 3 intercepts together like this. So I would have 3, 0, -3, 0, and 0, -9. I'd have all 3 of those intercepts listed for that particular one, and I would kind of put a comma in between each of those. So this is how you're going to graph something like that. Remember, if you have a square, you must use this U-shaped tool. It's not going to work if you have a line, because if you have a line, it's going to just have a line only. This other one over here, that's an absolute value. And that's not going to work either, because it has to have a smooth curve. So hopefully I've answered your question, how you would do something like this. And so if you're doing that by hand, so I'm going to go ahead and go back to the screen we were at before. And so I'm going to go back to our written notes that we have here. So if I go back to the way we have it before, you would basically find your 2 intercepts, and you would find one more point on the graph. And then you would have your 3 points that you can connect with a line like that. So this is a little bit harder than the ones that you have in the homework. The ones you have in the homework basically are just going to be that type where you have x squared minus 9 minus 4, some number like that you're going to have, and you'll get whole number answers. And so that's the type of graph that you would do. But that's the idea how you would do that. You'd have to factor it, set it equal to 0 to get the intercepts like we have here. And that's how you would do that kind of question. Let's move on to the symmetry. Okay, so symmetry, replace the y with -y. We get -y equals x squared minus 5x. Now this one, again, there's nothing I can do to make this look like the original one. If I multiply both sides by a negative, that's going to change both of these signs. So if I do that, so again, if I want to do that part, show that, let me do that here. If you're multiplying both sides by a negative, like this, you get y equals -y squared plus 5x. But doing that, that's not the same as the original one. So I'm going to put a no, that's not the same as the original one. So it does not have that kind of symmetry. X-axis symmetry, let's replace the x with -x, like that. And I get this negative is going to go away because I've got a square there. I have x squared, positive x squared. But then I get plus 5x. That's not the same as the original one either, because it's got to have exactly the same signs on it. So because of a plus, that's going to tell me that this is a no also. It does not have y-axis symmetry. Then I want to do the very last one, where I'm going to put a negative in for the y and a negative in for the x. So for this, I have negative y equals negative x squared. Oops, wrote that wrong. Square goes on the outside. And then I have minus 5 times negative x. This one, if I simplify it, I get negative y equals x squared plus 5x. Again, if I want to multiply this by a negative, so I'm just going to multiply the entire equation by a negative, both sides. I get positive y equals negative x squared minus 5x. That's again not the same as the original one because I got to have a positive y and a negative here. So because of this negative, that's a no also, which means if you get no for all three of those, that means it does not have any symmetry at all. So this has no symmetry at all on this one. Okay, so we have this next one. We're going to test for symmetry, put a 0 in for y, and solve for x. So I have x cubed minus 4x. Another one where I got a factor. I have x as the common factor here. So I'm going to, once again, pull out an x. I have 3 x's here. I'm removing one of them, which means that's going to leave me with x squared left over. I have negative 4x. If I divide it by x, I just have negative 4 left over. What I have left here, this is another type of difference of squares. This is like that my open math example I showed earlier. To do this, you're going to use the difference of squares formula that's on that. So this is x plus 2, x minus 2. Okay. You can also think of it as what two numbers multiply to make negative 4 but add to be 0. That's going to be 2 and negative 2. That's another way you can think about that as well. All these have to be set equal to 0. So I'm going to do x equals 0, x plus 2 equals 0, x minus 2 equals 0. And this one's already solved. If I solve this, I get x equals negative 2, and then this equals 2. Written as coordinates, that would be 0, 0. It would be negative 2 comma 0 and 2 comma 0. So this one has 3 x-intercepts here. Put a 0 in for x and solve for y. That's how we find the y-intercept. So we're going to do that. Y equals 0 cubed minus 4 times 0. And again, we get a 0. And as I told you before, 0, 0 is going to be both an x and a y-intercept. So if you solve this and you get a 0, 0 for the x-intercept, that means you're most likely going to get a 0, 0 for the y-intercept as well. It always happens that way. And so that's how that works. So we have, these would be the 3 intercepts that you would type in there, separated by commas. Again, don't forget, when you're putting these into My Open Math, make sure you remember to put the parentheses around that. Otherwise, it's going to give you a warning. It'll say invalid notation. It'll give you, and that'll be a reminder for you to put the parentheses on that when you type those in. Let's move on to the symmetry. Okay, so we got this one. Here's the original equation up here. We want to place y with negative y in the original equation. So we're going to do negative y equals x cubed minus 4x. All right, so if we multiply this by a negative, that's just going to change these two signs. So already I can just go ahead and put no on that because I already see that if I multiply by a negative, it's going to make this negative and that positive. That won't be the same as the original one. No matter what I do, I can't make it look like the original one. So we're going to say it doesn't have that symmetry. Next, replace x with negative x and simplify for the y-axis. So we're going to do that here, negative x cubed minus 4 times negative x right here. And I'm going to get, now this time I have a negative that's raised to an odd power. A negative raised to an odd power means that the negative actually is going to remain there. Okay, so I get negative x cubed here. Now this one, negative will give you a plus. Okay, so this one is not the same as the original one either. So this is another one that's going to be a no. So the question that often comes up that people ask is, if it's a no for the x-axis and a no for the y-axis, does that automatically mean it's going to be a no for the origin? Okay, like it was for the previous example. So let's go ahead and we'll find it. We'll find out the answer here. Let's go ahead and do that and see if that's going to be the case here. Okay, so origin, you're replacing both of these. I have negative y equals negative x cubed minus 4 times negative x. So I have replaced the y with negative y, replace the x's with negative x that I have there. Let's simplify this. Okay, so again, we talked about this before. A negative raised to an odd power, you get negative x cubed, and then this is going to be a plus 4x. Now, it doesn't look like it's the same as the original one, but remember, you should always try and multiply both sides by a negative. So I am going to do that in this case. So I'm just multiplying the entire equation, both sides, by a negative. Technically, what I'm doing here is multiplying both sides by -1. So -1 multiplied by that. This gives me a positive y. This gives me a positive x cubed and a minus 4x. Notice that this one that we get, that is the same as the original one. So that's going to now be a yes. So this one only has origin symmetry. So just because you get a no for the x-axis and the y-axis doesn't necessarily mean it's going to be a no for the third one as well. Now, it is possible also for you to have more than one type of symmetry. If you have like an x squared plus y squared, something like that, then you actually might end up getting all three symmetries for that. So you just have to basically just show the test for each one like I did here. The work that I'm showing here would be sufficient there to test for symmetry on that case. And so that's the case there on that one. Okay. All right. So that is actually everything for 1.2. Okay. So I'm going to do an example here. I'm going to let's do. So this is like a bonus problem. Okay. So that wasn't originally in the notes. What I'm going to do is find the intercepts and graph y equals x squared minus 100. Okay, so I'm going to do one of these types of problems that was from the similar to the homework one, and just have one extra practice problem, so that way you see all the work shown for this one, and you can do that one that's in the notes there. So let's do that for this here. Okay, so find the intercepts and graph. All right, so first of all, we're going to if you want to find the x-intercept, you're going to put in a 0 for y. So I have 0 equals x squared minus 100. That means I would have x plus 10, x minus 10. This is a difference of squares. Okay, you're looking for two numbers that multiply to make -10 but add up to 0 because there's no middle term here. Or you can just think of it as using the difference of squares formula. So either way, you're going to get x plus 10, x minus 10. If you set both of those equal to 0, you're going to get x is equal to -10 and x is equal to 10. Okay. As coordinates, that would be -10 comma 0, and it would be 10 comma 0. Okay, so that would be the x-intercepts there. Okay. For the y-intercept, you want to put in a 0 for x in the original equation right here. If you do that, you're going to get 0 squared minus 100. And you get y is equal to -100. That means that you would get 0 and -100 as the y-intercept. So on the first blank that you have with this problem in My Open Math, what you're going to do is you're going to put these two in there, then you'll put a comma and then add this one. So all three of those will be typed in there for that. So when you do these problems in My Open Math, what you want to do is you want to always start, we're going to go ahead and on paper first, I'm going to plot all these points here. So what I'm going to get is I have the x-intercepts here. This is going to be the negative 10, 0 right there. This is going to be the 10, 0. And then down below here, way below, down there, this is going to be the 0, negative 100 at that point. When you use the tool in MyOpenMath, you actually want to click on the Y-intercept first, okay? Because that's going to be the very lowest point of the graph. So when you do these again, you're going to hit the, make sure you hit the tool that's got the, you want to do the upside down tool. So this one right here, that's the button that you want to click on in MyOpenMath. And then you're going to click on this point right here and then move your cursor until you have the cursor crossing at negative 10. So this is at negative 10 and this is at 10 right here. So move your cursor until it goes through and you'll see it make this shape over there just like that. And that's what it's going to end up doing. So this is how you're going to complete this problem. There's 2 of those type in the homework. And then everything else that's in the homework is something we've talked about here with the notes by doing the test for symmetry one on there. And so that's how you want to complete that one. So that's the only other graph that you're going to do there on this one. And so is to do that part. Otherwise, there are some questions where they're actually going to give you the graph and then you just read the intercepts off the graph itself, so that way you don't have to find them algebraically. There's a couple questions like that as well. That's even easier than the ones one like this, because one like this we had to do algebra to find the intercepts. But if they give you a graph, then you can just read those directly off the graph itself, and you don't need to do any algebra on that. So that's the other types of questions that you'll see in this section. Does anybody have any questions on anything in this section before we move on to the next one? Okay, I'm not getting any questions. If you think of something, then you can always go back to it. So let's go on to, so this is actually everything. This is all the notes for 1.2 that we completed here. So we're going to go on to 1.3, and 1.3 is, again, it's a review section. You might have seen this before. It's talking about graphing lines by using slope and Y-intercept. Okay, so that's going to be what we're going to talk about in this section. So first of all, the first part of this is in your notes already. This is all written out for you. Okay, so we've got the slope formula. So if you have 2 points, x1 y1 and x2 y2, that's here. We have 2 points and we're going to connect them together with a line. And so by doing that, we have something that's called a slope. Now, a slope is a measure of what the slant is going to be on a line. It might be like this, or it might be, go up very, very slowly. And slopes can be positive, negative, or 0, or undefined. Okay. Now, if you have 2 points, then what we have here is we have the change in y. So this part right here would be y2 minus y1, and this is x2 minus x1. We actually talked about this yesterday and had the same picture when we talked about the distance formula earlier. So if you do that, then the slope is going to be the change in the y over the change in x. So that's how we get this formula right here. Now we use the letter m to indicate the slope. I'm not sure why we use m for that, but that's just the letter that is standardized that we use in math is m. y2 minus y1 over x2 minus x1. So I'm gonna draw little sketches for each of these. Positive slopes will increase as you move from left to right. So it's gonna kind of be like that. So if you go from left to right, the graph goes uphill. Negative slope would be slanting this way. So as you go from left to right, the graph is going down or falling, going downhill. As you move from left to right, that's considered a negative slope. Horizontal line, we have right here. So horizontal line would be that, and then we have a vertical line would be considered undefined slope. So you can also think of it as an infinite slope. It's infinitely large, so we have it up and down like that. So that's all the different types of slopes that we could have. You either have a positive slope, negative slope, a slope of 0, which would be horizontal, or you might have a slope of infinity, which is going to be a vertical line that we have. So we're going to use this formula right here, this y2 minus y1, this formula, slope formula. We're going to use that here in order to find this slope. Now these points, like we talked about yesterday, you can label them either way. So I can either do x1, y1 or x2, y2, doesn't matter, or I could do x2, y2 and x1, y1 like I'm going to do here. I'm going to label them this way and show you that you'll get the same answer as the one in the notes, because in the notes I have this reversed, but it shouldn't matter. You'll get the same thing as a result. I'm going to use this slope formula right here. So it says y2 minus y1 goes on top. The way I have this labeled here is y2 is 3 and y1 is 4. So I have 3 minus 4 on top. On the bottom, I have -1 minus 2. So that's going to give us -1 over -3. And the negatives are going to cancel out. And so this is a positive line. And it says here that positive slopes will increase. So I'm going to say that this one right here, this line increases because it has a positive slope, which means that as I go from left to right, it's increasing or going up like that. So we say it increases in that case. Next one, we're going to do 4, -1 and 3, -1. Let's label that the same way, x2, y2, x1, and y1 for this other point here. We're going to use the same formula that we have up here, y2 minus y1 over x2 minus x1. And we'll just do that with the points that we have labeled there. The y's go on top, -1 minus -1. On the bottom, we have 4 minus 3, x2 minus x1. Now on top, we have -1 plus 1. You're actually going to get a 0 there. And then we get a 1 on the bottom. So if the 0 is on top, this gives us a 0 for the answer. It's okay to have a 0 on the top of the fraction. If you're thinking about wondering whether it's undefined or not, undefined only happens if you have a 0 on the bottom, which we don't have here. We have a 0 on top. So that is 0. So if we get a slope of 0, that means this is going to be a horizontal line. Okay, so that's horizontal. Let's do one more of those. We have these points right here. And so again, I'm going to label this as x2, oops, it's x squared. We want x2, y2, x1, y1. We're going to put that into the slope formula again. The y's go on top. So on top, we have y2 minus y1. -2 minus, be careful with your minus signs. You're subtracting a negative. So you have to make sure you put these in parentheses because you are subtracting a negative number. On the bottom, 3 minus 3, x2 minus x1. On top, we get -2 plus 5. So that's going to give us a 3. On the bottom, we get a 0. Now this time, we're dividing by 0. So this is undefined. Okay, so if it's undefined, that means you have a vertical line there in that case. So we're just going to put it into the formula, and you just compare the slopes, and that's going to tell you what kind of line it is based on that. Okay. Next, we're going to move on to the slope-intercept formula and linear function. And so these three formulas are ones that we're going to look at. These are all in your notes. Okay, but we've got slope-intercept is y equals mx plus b. Slope is the m and the intercept is the b. That's why it's called slope-intercept formula, because if it's written out this way, you can easily tell what the slope and the y-intercept are. We have that. Next, we've got linear function. Linear function is really the same thing as this. It just means that we're using this notation. We're going to talk about that next week when we get to chapter 2. Chapter 2 talks about functions. And what this means here is if you've got an f with a little x afterwards, this is what we call function notation. And so it's the same exact thing as this. It just means that it's considered a function instead of an equation, but it's really the same thing. And the other formula we'll talk about is called point slope formula. So point slope is used when you are given a point and a slope. Now, it doesn't have to necessarily, the point you're given doesn't have to be the y-intercept. It can be any point on the line. So if you're given a slope and any point that's on that line, we can put it in this formula, and that's going to give us a way that we can find the formula given that information, plug it into here, and we have that. Okay. So these next questions are going to have us use the information and conditions to write an equation for each line in slope-intercept form, and they also want the point slope form as well. Okay, so actually what we're going to do first is we're going to use the point slope formula first, and then we're going to solve for y, and that's going to give us the slope-intercept form. Okay, so this right here, they give us, this is an m, they give us, and this is x1, y1 is what they give. So, excuse me, the first thing I want to do is use the point slope formula, which is written out just like this. I'm not going to plug anything in for the y or the x, but everything else I'm going to plug into. So I'm going to leave this as a y. The y1 is -1, so I'll go ahead and put that there. The m is 8. And then the x1 is going to be a 4, just like that. So notice I put everything in except for the y and the x. You want to leave the y, x alone because that's going to be part of your formula later with that. Now, if I simplify this, I get y plus 1, and I'm just going to leave this alone as is. So this point right here, this is going to be that's the point slope formula. So that would be the first answer they're looking for. They want you to find the point slope form. That's it. Okay. Y plus 1 equals 8 times x minus 4. That is the point slope form. But I'm going to continue with this and solve for y. By solving for y, that's going to put it automatically into the point slope form like that. So let's do that next. I'm going to continue. So that's one answer already, point slope, but I'm going to keep going with this. I want to multiply out the 8 like this. And then I need to solve for y. So I'm going to subtract the 1 from both sides, and I get y equals 8x minus 33. This is the slope-intercept form. So now that's the two answers we're looking for, point slope, and then if you solve for y, then it's the slope-intercept. So that's the y equals mx plus b 1. Even though we have a minus sign, that's okay. It's still considered to be in slope-intercept form. You do have to make sure, though, when you write the slope-intercept form that the x comes first specifically here. That's why we have the 8x has to come first with that. All right, now next, we want to do another one of those. And so this, we're going to follow. So I have this formula that I wrote up here. And so we're going to use that same formula for this next question. For this one, I have the m is -3/5. I have x1 is 10 and y1 is -4. I'm going to put that into this formula, the slope-intercept form here. So I'm going to do y minus y1. So again, I have y minus -4. That's going to equal -3/5 x minus 10. So that's x minus x1. Okay, so let me do one more step, and I'm going to turn this into a plus. So y plus 4 equals -3/5. I don't want to multiply this out just yet because I want to write my answer down for the point slope. Okay, so point slope would be just this. We don't multiply. We leave the m there with the parentheses. That's going to be point slope. If we want to get the slope-intercept form, that's where we keep going with this. We're going to take the point slope form, keep going, and solve for y. So y plus 4 is going to equal -3/5 x. All right, now I'm multiplying both of these here. So I want to take -3/5 and multiply it by -10. Let me do that off to the side over here. -3/5, and I'm multiplying that by a -10. So when I multiply that, I'm going to get 30 over 5, and then that's equal to 6. So when I multiply this, I'm going to get a plus 6. And that's again because of this. I could also cross cancel on this. Divide this by 5, I get a 1. Divide that by 5, I get -2. So I would still have -3 times -2, which should still be positive 6. So either way, when you multiply those, you'll get a 6 there. Next, I'm going to subtract the 4 from both sides. Y equals -3/5 x. And then 6 minus 4 is 2. This is going to be the slope-intercept. Okay, so slope-intercept form on that one. That's the two answers. All right, now part C is a little bit different. Okay, so this is passing through -3, 6 and 3, -2. What's different about the problem we just did earlier is the problems that we did above here, it automatically told us what the slope is and one of the points that it passes through. We don't have this. We have points, but we don't have the slope. So for this kind of problem, what you would have to do first is you first want to use the slope formula. So this one right there. So I'm going to label this as x2, y2, x1, y1. And I'm going to plug these points into that, and I'm going to first find the slope by using that formula. So let's do that first. We're going to do y2 minus y1, 6 minus -2. Get a little bit more clear, -2, there we go. Over x2 minus x1, -3 minus 3. And that's going to give us +8 over -6, which if we reduce that, that's going to be divide both sides top and bottom by 2, and we get -4/3. So now we know the slope. We also have this point here labeled as x1 and y1. Now, when you do the point slope formula, you can actually use either one of these 2 points. So even though I have labeled the second point as x1, y1, we could have also used the first one as well. So it really doesn't matter, but since I have this labeled already, we'll go ahead and use it. We're going to do y minus y1, so y minus -2 equals, here's our slope, -4/3, x minus x1, which is the 3. So if I simplify that, y plus 2 equals -4/3, -4/3, x minus 3. This right there is going to be the point slope right there. I want to continue. So y plus 2 equals -4/3 x. And then if I take -4/3 times the 3 here, the 3's are going to cancel, or I get 12 over 3, which is going to be a positive. It is going to be a plus because I have negative and negative, so it's a +4 there. Subtract the 2 from both sides, and I get y equals -4/3 x, and that's going to be +2. This is going to be the slope-intercept form right there. Okay, so we have that. We're going to do one more of these type. All right, so this one has x-intercept and y-intercept it's given. Before we can do anything with this, let's first write these as coordinates. And then we'll get 2 points that we can use the slope formula in order to find the answer on that. So this one can be written as -1/2, 0. -1/2, 0, it's an x-intercept. And then I have 0, 4 for the y-intercept. For x-intercept, the y-coordinate is 0. For the y-intercept, the x-coordinate is 0. So we have these 2 points. I want to use the slope formula in order to find the slope here. So I have y2 minus y1, x2 minus x1. I'm going to label this as x2, y2, x1, y1. Okay. Put these into the formula, and I get, this is a 1 here. Okay. put that into the formula, we're going to get here x, change in y over change in x. So I'm going to do 0 minus 4. In the bottom, I have -1/2 minus 0. So x2 minus x1 goes in the bottom. Y2 minus y1 goes on top. On top, I'm going to get -4. In the bottom, -1/2 minus 0 is -1/2. If you're dividing something like this, you're going to take the top number, which I can write that as a fraction, is -4/1. I'm going to multiply this by the reciprocal of the bottom one. If I flip that, it becomes -2/1. When I multiply, I just get 8. Okay, so 8 is going to be the slope on this one. Now I want to get the point slope form on this. So I have y minus y1 equals m times x minus x1. So I have y minus y1. I already have this labeled already. Let's go ahead and use that. Y minus 4 is going to equal 8, and I have x minus 0 for that one. This is going to be the point slope form there. And then if I continue with this, I have y minus 4 equals just 8x, because that's what all this is here. If I add 4 to the other side, I get 8x plus 4, and this right here is the slope-intercept. Okay, so that's the slope-intercept there would be this one here. Okay, so I have my two answers now. Point slope, and actually this one, the point slope could also actually be this guy right here, because basically this one will simplify into that one. So you could also put this for point slope and then this one for your slope intercept on each of those. Now, another thing that they're going to talk about in this section is horizontal and vertical lines, like that. That's what we have right here. All right, so this one, we've got, if you have x equals a, so if it starts with x equals something, that's going to be a vertical line, like we have here. So as we see, the vertical line crosses the x-axis at a. So the equation is x equals a. For the horizontal line, it starts as y equals, but notice that there's no x in here. It's just something like y equals 4 or y equals 3, something like that. It's a horizontal line, and it's going to cross the y-axis at the value of b. And that's the equation for the horizontal line, is y equals b. So we have x equals a and y equals b. Those are the two equations for specifically horizontal and vertical lines that we have for that one. One of the types of problems that's going to ask you with this is, says write the equation of a vertical line containing the point -2, 3. Well, let's just draw a quick sketch of this. -2 and 3. So let's plot that point. Again, start from 0, 0. We go to the left because it's negative, then we go up 3. Okay. And it says we want a vertical line that goes to that point. So let's draw a vertical line. So what I've done is I've drawn a vertical line that goes through the point -2, 3. And now it's asking me to write the equation for it. Well, if we look at this picture here, wherever the line crosses the x-axis, that's what your equation is going to be. So I see that this crosses here at -2, which means I'm just going to put x equals, because it's a vertical line, so I need x equals first, and then where it crosses at -2. That's the whole answer. You would just put x equals -2, and that would be it for that one. So if it's vertical, it's x equals. Well, let's do a horizontal line as well. Actually, this one, you know what? This is a typo. Apologize. This actually should have been horizontal. Okay, so let's do, horizontal. Okay, so we're going to do a horizontal line instead. We already did vertical up here, so let's do horizontal down below, something different. Okay, so this one we're going to plot 1, 2, 3, 4, 5, and 1, 2, 3, 4. We're going to go 5 to the right and up 4 and make a dot right there. And it says we want to make a horizontal line that goes through 5, 4. So I would draw a horizontal line like this going through that one. And I want to write the equation for it. If I look up here, we have that the equation is y equals something because it's horizontal, and y equals wherever it crosses the y-axis. That's what we put. This case right here, the height is 4, so I'm going to put y equals 4, and that's going to be the answer for that one. Okay, so I have that. So now I have vertical and I have horizontal, and that's going to be how you do each of those. So there's a question like that in the homework as well. At this point, I'm going to go ahead and stop at this point because I want to leave a little bit of time at the end. Again, I always try and end at about 10 minutes after or so to give people time to ask questions. And so does anybody, I'll just kind of open it up. Does anybody have any questions on anything that we talked about for today? You feel free to unmute yourself and ask, or you can also use a chat box as well, either one of those. Okay. Any questions anybody have before we end this meeting? All right, well, I'm going to go ahead and close this. Now, we're not done with this section yet. We are going to continue with this tomorrow. So I will end this now. And if you think of something tomorrow, you can always ask it at tomorrow's lecture as well. But just enjoy the rest of your day, and I'll see all you guys tomorrow.